Hello everyone and welcome to today's learning session at Lambert Labs. Today's presenter is Guy King. So Guy, please take it away.
Thank you, George. Yes, today I'll be talking about setState callbacks in React. So to start off with a bit of background about what state is in React. We're not going to go into too much detail here. Hopefully this slide will just sort of give you a feel for what it is, and hopefully it will just make the example that's going to follow a bit easier to understand. But really, sort of in order to be able to talk about states in React, we first have to mention really components, and that's what the first 2 points are about. I think it's also probably worth drawing attention to the last point in particular. Here, we should be aware that when you want to change state in a React component, you can't just sort of update the value of the variable. You have to call this special modifier function. And that will sort of become clear in the example that follows. And I guess, I don't really have like a snappy sort of one or short sentence that sort of sums up very well what state is in React. But I guess I like to think of it in terms of an example. Often, sometimes you can ask yourself the question when you're writing a component or working with a component, does this component need state? And the sort of way I sometimes think about that is if you imagine a user sat in front of a computer looking at a browser and looking at your page. You can imagine if that user sits there for an infinite amount of time, does that page ever need to change? So you can imagine if that page is some kind of article, there's some text, there's some images. Well, yeah, let's imagine that it's just some text, and the text is referring to the date of some historical event, like the date Donald Trump assumed the presidency in the United States. That is never going to change given any external event, let's say in the outside world. Your page is never going to have to update that date. And similarly, we can imagine if the user is clicking around on that page, it doesn't matter what they do, they can sit there forever. The page never needs to update. It always shows the same content. So in that situation, you can say my component does not need state. On the other hand, if there is something the user can do, like click on a button, and let's say when they click on the button, the background color needs to change to blue, then you do need state. And similarly, if it doesn't have to be the user that brings about this change, it could be your page might be showing some data updating in real time. So if that data changes in the outside world, then again, your page needs to update. And in both those scenarios, you need to have states in your React component. So yeah, this is more the sort of nuts and bolts. So how do you set states in a React component? So firstly, I'm talking about a functional React component. You can write class-based components, but everything in this talk is going to be for functional components. So you basically use this useState function. It's something called a React hook. It's something that React provides you as part of the framework, and you call it. You pass in an argument. It returns an array of 2 elements, and this sort of funny syntax is just saying, this call returned 2 elements. The first element I'm going to store in the variable myState, and the second element I'm going to store in the variable setMyState. The first element returned by this call is the variable itself containing the state's value. And the second element is this modifier function we referred to in the previous slide. And this is the function you call to update the state. So, and also this value passed in here, the empty string, that sets the initial value of your state. So here, after this line has been run, the state is stored in this myState variable, and it's set to an empty string. And then we call our modifier function. We pass in the new value, so the state has now updated from an empty string to this string myValue. But there's another way you can set state. You can use a callback function, and this is the callback function that's the subject of this talk. So here rather than just passing a string literal or an integer or some other primitive, we pass in a function. This function has for the one argument, and that's the previous state or current state, depending on how you look at it. And the function returns a value, and the return value of the function is what is used to update the value of the state. So here it's doing the same thing as before. Here in the second line, we are actually making use of the current state, but this argument, we're joining it. But of course, you might say, well, why do I need this callback function? Why can't I just do this third line? If if the new state I want to set depends on the current state, well, I can just reference the current state here, and that's absolutely true. But yeah, so sort of to answer the question, what purpose does this callback function serve? Well, it's because React updates state asynchronously, and that's sort of relevant here because if you call your modify function twice, and in the second call, the value that you want to update the state to depends on the result of the first call, by the first call also updates the state, then React is saying that it's actually not going to promise you that by the time you call the second update state function, it's not promising that the first one is completed. So it might look like it has, but actually, from the framework's point of view, it's not saying to you you can write your code on with that assumption made. You can't. So that's sort of why you have to think about this callback function sometimes. Now, most of the time, it's not an issue. We'll sort of see that in the example. But sometimes it can lead to unexpected behavior, and we'll also see an example of that. So let's start off with this sort of happy case example where everything happens as expected. And okay, so hopefully this is our example. On the right here, we've just got a very small component. This is the JSX, which is what you see in terms of the HTML elements rendered on the page. We've got our state variable and our modify function here, and we've got an event handler here that is triggered when we click one of each of the buttons. So for now, our event handler, when we click the add button, it sort of does something very straightforward. It just takes whatever the state value is and it increments it by 1, and it sets that to be the new state. And if we try out this here, so it sort of works as you expect. We just advise fine. So this is all good. Nothing unusual going on here. Now, if we were to just change our event handler to be this one here, here we're doing exactly the same thing, except we're introducing a 5-second delay via this setTimeout call, and after the 5 seconds have elapsed, we do exactly the same thing, set counter to be counter +1. Okay, so this is our second example, and so now this time, so I click twice, and after the 5-second delay, it increments the first time. You might be thinking, well, after another 5 seconds, won't it increment again? And it should see too. It won't. I think 5 seconds have passed. You just have to trust me on that. But yeah, we could sit here forever. I don't think that's going to change. So what's going on then? So you might be thinking, well, if all we've done here is added a 5-second delay, why doesn't the exact same thing happen as in the first example, but just with everything shifted back 5 seconds? And yeah, if you're sort of thinking about this synchronously, you can sort of think of this order of events. You click the add button, that triggers the event handler. It calls that function. In that function, we hit this delay first for 5 seconds. Those 5 seconds pass, and then we actually do the update of the state. that function finishes, it exits, and then because this is synchronous, the first function finishes. Well, let's start the second function then, and it does the same thing. It gets blocked for 5 seconds. It then does another increment. So by this time, we basically have 2 increments. So you'd expect at the end to see 2 rather than 1. But the problem is that React doesn't update the state synchronously. It does it asynchronously. So what happens is when we clicked the add button the second time, React actually, right at that very moment, it will grab the value of the state at that point in time. It is aware, of course, that you previously did click it the first time, and that also triggered a state update. But that first state update, that's non-blocking. So the second one doesn't say, oh, I've got to wait for the first one to finish before I do my thing. It doesn't. It's non-blocking. So it just, as soon as you click it the second time, it grabs whatever value is in state at that time. And of course, because of the 5-second delay that I introduced, the state hasn't actually updated yet. So that's why on both clicks, the state is actually stuck at 0. So both of them, all they do is bump them up to state to 1, which is why we saw what we did. But maybe get more of a feel for that also. It's true that if we were to click here, wait for the 5 seconds for it to increment the first time, and then we clicked the second time, in 5 seconds time, it's going to increment to 2. So you can see whether this is the problem actually does depend on the user, depending on how quickly the user interacts with the UI. So the next question might be, well, what actually happened in the happy case then? Because there, things were happening asynchronously. We were, using the sort of standard way of updating the state. Well, actually, what happened is the fact is that React is actually quite quick and efficient at updating the state. So although in the first example, everything was happening still asynchronously, the point is that React was quicker than me, the user. It managed to update the state in time before I clicked it again. And yeah, I think that's why I'm saying in a lot of the time, this sort of distinction is not something you have to worry about, because from the user's point of view, they can't tell any difference. Okay, but nonetheless, we're going to ask ourselves the question: well, how do I sort of get back to the happy case, and how do I fix this problem? So, in that case, what we can do is here in this new event handler function, basically the same as the previous one, only now when we pass in our value to our modifier function, we actually pass in this setState callback function here, which does the same thing as we were doing before. It just takes whatever the current state is and adds 1 to it. But the key point is that we're passing in the callback function rather than the value of the new state directly. So now if I do my click twice, so there's the 5-second delay again, but then quite soon afterwards it updates, and both clicks a bit quicker. For example, again should get the same result. Initial 5-second delay, and then it updates. So that is sort of the fix, so to speak, to return to the happy case. And why does that work? Well, because we've passed it the callback function. What this means is that React is now saying, oh, okay, you've given me these callback functions, so I'm only going to run the state update once all previous updates are finished. And sort of everything is sort of queued up nicely now. It doesn't matter how many times you click, they're all sort of queued up in the right order, and each state update is only going to happen after the previous one has finished. So in conclusion, I've sort of already touched on the fact that, as in the very first example, you don't need to bother with this callback function. and the user actually doesn't notice. So in this particular example, it's true. In terms of your code, it doesn't really matter which method you use. But the point is, in the unhappy case, you can imagine, so there I artificially introduced this 5-second delay. You can imagine if in your event handler, that latency comes about for a real reason. So yeah, as per here, I've said, you can imagine if in that event handler, you actually make an API call, for example, and let's say when you want to update your state, you actually need some data returned by that API call. So you have to wait for the API call to finish, and that latency, however long it is, it could introduce a problem. So yeah, again, that obviously depends on the latency. Also depends on sort of how quickly the user interacts with the UI. There's a limit on that as well, of course, that the human can only sort of interact with the UI as quick up to a certain point. But yeah, that latency could be very large. We don't know. That's the point. The very final point is just saying, well, actually, yeah, if you were sort of reviewing code, being very pedantic, you could actually say, well, yeah, I can see to the end user, it's not going to make any difference, but actually for the code to be technically correct, I think you could make a fairly strong case to say, well, you should actually use the callback function whenever the state update that you're performing depends on the current state. Yeah, so that's the end of the talk. Thank you for listening. If there are any questions in the audience?
I've got a question. So, I mean, from what I can see, it sounds like we should be using a callback wherever possible. That's what you just said. It should be. It could be picked up on code review, although you might consider it pedantic. But I don't know. It seems to remove doing that would seem to remove any kind of remove the potential occurrence of any unexpected behavior. Is there any way to automate this? What I mean that is there any tool that can pick up when you're not using a callback, whether it's in the React build or some kind of static code analysis tool? I don't know.
Yeah, I'm not aware of any sort of static analysis tool that would do that. But yeah, I think it could be possible. I mean, because the sort of rule for using the callback is quite straightforward. It's whenever you perform an update to your state that uses a value in the current state. I think that's something that a linter or some kind of parser could detect fairly reliably, I guess. So yeah, from that point of view, I think that would be feasible. But yeah, like I said, I haven't as of yet come across that. But yeah, that would be quite interesting to have. Yeah.
Want to check if it exists, and if not, you know what to do, right?
Yes, exactly. Yeah, but yeah, like I said, it's one of those things. Often, if you sort of manually test the sort of UI itself, especially if you're running stuff locally where everything happens, with very low latency, you might be quite unlikely to pick up what could turn out to be a bug in the, let's say, in a production environment where there is sort of real network latency going on. Yeah.
And you mentioned in terms of the state updates, is there a recommendation on the latency for that? I mean, what from your experience in working with React, what at what stage does the duration of a state update start to, I don't know, have a negative impact on user experience? Or is that a bit too generic a question?
No, I think that's a very fair question. I think we're probably talking in the order of, maybe seconds rather than milliseconds, let's say. If we're talking about milliseconds, then at that sort of level, perhaps it's too short a latency sort of for the user to notice, I guess. But I guess anything, any sort of interaction the user performs with the UI, however long that takes, if the latency is greater than that, then you might have to start thinking about this problem.
Sure, thanks, Ben.
No problem.
In your code, you use this variable pref counter. Where does that come from? On line 11.
On line 11.
Yeah.
Yes. So that's just like the argument. So well, when you pass in the callback function to the state modifier function here, setCounter, React expects you to pass in a function that takes one argument. That's just dictated to you by the framework. You can call that one argument, I think, whatever you want, but the point is it should be part of the function definition. And actually what that argument represents is the value, the current value of that state. So here you're setting the state of something called counter, this counter that we called out here. And so this argument here represents the current, again, current or previous, depending on how you're looking at it, but the value that you might want to use when you set it to be a new value. But to answer your question, it's just something that the framework gives you, basically. You don't have to worry about it.
Yeah, that makes sense. Yeah, thanks.
Cool. Well, if there are no further questions, then I guess that's the end of the presentation. And thank you everyone again for listening. Cheers.
Thank you, Guy.
Thanks, Guy.